I'm going to dive right in then, and maybe just start with the first question that I asked our CEOs, which is, you saw Craig Giffey's presentation, or Dave, I don't know if you caught maybe the end of that, but was there something in that, the findings there, that really surprised you or you didn't expect to see? Maybe we'll just start right here, Steve, at the end.
Sure. First, I'd like to commend Deloitte for that study. We've got a lot of studies that look at R&D spending in different perspectives. This one, taking a look at it from the manufacturing perspective, is particularly nice and is an in-depth study in certain areas looking at the role of advanced technologies. It's one more voice, however, that shows really the risk we're at as a nation in terms of resting on our laurels. The R&D investments we've made that really have benefited this nation for many, many decades take a long time to come to fruition. We heard that from previous speakers. And one thing that concerns me, either it's the statistics we saw earlier or what we just saw right after lunch, is that we continue to slide in terms of our investment, whether it's in basic research or applied. And I think that's one of the most sobering messages there, despite the fact that we still are a very competitive nation. And I guess what I look at is, imagine if we had the commitment and the discipline to continue a robust investment in R&D, how much more competitive and prosperous we'd be, and indeed could lead the world. So that's one of the things I was most concerned about. The other thing I took away from it was the fact of how important you could see information technologies, digital technologies generally, in that list of things he showed, coming up in probably about half the items. You saw the importance of that and what we're doing, and the question is that going to be a strategic investment area for the U.S. going forward?
Right. Subra?
So I'll just make one point related to that. But before that, because we talked about this morning about funding and also the point that you just made about sustaining funding for research, just to put it in context, NSF's annual budget is about $7.3 billion. Americans spend $7.3 billion every year on potato chips. And so that sort of calibrates the level of funding. One item that I think is going to be critical, especially in the context of energy and manufacturing, and especially in the context of energy, is not just the role that technology plays, but how humans adapt technology, abuse technology, use technology intentionally and unintentionally is going to play a huge role. So for universities, it's very important as we do research, we just not just focus on newer technologies, but also think about how the technology will be used and abused and adapted. A very good example is Nest, which is a company that's very much in the energy space, created by a Carnegie Mellon University graduate, was sold to Google last year. And that kind of technology exists. But how do we make sure that more and more people will use it along with the Internet of Things?
So Dave, I'm not sure when you came in for Craig's presentation, but one of the really interesting results was that the U.S. has continued to move up in the survey from 3 to 2 to 1. And one of the reasons was a focus on advanced manufacturing, which is obviously near and dear to your heart. I mean, does that, wouldn't think that would surprise you, but does it?
Well, first thing I want to say is I'm having flashbacks. When I was a graduate student, I took Supra's mechanics course. I was coming in a little cocky from UC
He did very well.
I came in a little cocky, and I totally bombed the first midterm, but I made a comeback, so feeling okay about that. Well, I wanted to maybe go a little bit countercurrent on this. Is that there's no doubt that we need to be investing more in innovation, and it's such a no-brainer, as my colleagues have said. But one thing that I've been focusing on at the department, and it's been really catalyzed and enabled by our partnership with the council, especially in advanced manufacturing and in national lab impact. How do we get as much as we can out of our national labs in terms of competitiveness and advanced manufacturing competitiveness, is that even with the same number of dollars, I think we can get more output by doing things right. And I think that what I've noticed the biggest opportunity, and I think Steve and I agree, is that to create a more commercially aware culture within our research institutions, and a culture that's not afraid of commercialization in business, that still does great basic research and loves doing that and does a lot of that, but that culturally isn't afraid to be entrepreneurial and think about commercialization. And so Just even from, we have statistics in our national labs from fiscal year 13 to 14, some of the work that we've enacted, Steve and I and others, to try to change the culture, we're seeing increases in a number of indicators for commercial impact or engagement increase by 20, 30% just within a year. And so I think that there's a great opportunity to get more out of the same number of dollars, that there's nothing wrong with, the national lab researchers are going to innovate in brilliant directions no matter what, but if that direction is going to matter is a big question. And if you have commercial engagement early on, brilliant early stage research can be potentially more relevant. And very briefly, we just recently rolled out a program called LabCorps, inspired by iCorps, which I know has started under your watch. And we put 14 teams through this entrepreneurial training academy, 8 weeks. And I attended the graduation. You looked at these 14 teams, about 40 researchers. It's like their mind had been turned on. They weren't afraid of commercialization. They were excited about doing customer calls and those kind of things. So we're doing a number of things in that zone in the national labs and universities. So I think that's an opportunity. So we can get even more for the same number of dollars.
Do we have the and I apologize, this wasn't one of the questions I previewed for anybody, but I mean, you just raised the point of trying to do more with less, but the importance of entrepreneurship. Do we have the tolerance for the risk taking that's needed to go down that road?
So I want to follow up what Dave's saying, is I think that at the labs we have over 30,000 scientists and engineers and support staff who really are focused on what the nation needs, and they're there because of the mission draw. We talked about that a little earlier. They're really enthused about the opportunity of getting those research results out of the laboratory beyond the original mission and then leveraging it to the economic advantage of the United States. What I think is different, and it's because of leadership like Dave Danielson, the Secretary of Energy, is that they're seeing it as being important. Our scientists and engineers will work on those things that we're told are important and are national priorities. And in the past, to be frank, a lot of what's gone on in commercialization and tech transfer has been mentioned, but not nearly as prominently as has been done under this administration and with the Secretary of Energy. And so when they see that kind of importance, they get excited about it. The second thing is actually giving us the means by which we can engage industry. We have a long ways to go. One of the things, the cultural mismatch, things like that we can talk about. But whether it's LabCorps or many of the other initiatives, including some very innovative pilot programs, experiments that Dave and others in Office of Technology Transitions under Jetta Wong have launched, are really giving us now the means by which we can engage industry. Because there are certain basic things we have to worry about, like how do you pay for the staff time to do that? The department's now giving us the tools we need to do it, and I think our scientists and engineers are enthusiastically responding, and that will allow us to get an extra bang for that investment buck of the taxpayers' dollars.
You asked about doing more with less. One of the guiding principles when we were discussing whether to start the iCorps at the National Science Foundation 4.5 years ago was how do we put as little money as possible but get the maximum bang for the buck, taxpayer buck, out of this. So out of a $6 billion a year funding for basic research across the country, in the first year we decided to put $6 million, 0.1%. to essentially take discoveries that have already been made, most of which don't see the light of the day, so that we can grease the wheels, let the private sector take over. So it's not to do new research, but to take existing research and move it to the marketplace so that it realizes economic value out of it. That was the goal behind it. And in a university setting, you can also do this. I'll give you one example from my own institution. So in the last 5 years, 125 companies have been spun out of Carnegie Mellon. This year, we will create 42 companies. In the last 5 years, those companies attracted $500 million from outside of the university in terms of venture capital funding. In the energy space, Acqueon is a very successful example. The university policies do matter. It doesn't cost any money. So about 10 years ago, we created a policy called 5% in Go in Peace. So the idea would be to essentially make it easy for inventors and professors and students to spin out companies. And the goal is not to maximize our royalties from licensing, But to make it wildly successful so that the professors and alumni, when they become financially very successful, they will donate even more money to the university. That's the policy. And that has led to a fourfold increase in the number of disclosures, patent filings, et cetera, in the last 10 years.
How's it done for the endowment?
There is a time lag, so you have to wait. So the person who sold Nest graduated 10 years ago, and he's only 32. So.
Well, I think this gets to a really important, very contemporary question around, I think it relates to clean energy manufacturing, but advanced manufacturing more broadly, is what's the new innovation model by which we are going to be able to tap into our brilliant minds in universities and national labs, get entrepreneurial startups to be created and grow, and then get those startups to be able to get the financing, and then have the partnerships with the bigger companies so that they can actually scale. And so I was a venture capitalist during the kind of clean energy venture capital wave. And for anyone that's been paying attention, that's basically gone down to zero for early stage innovation. I think it's reasonably true for physical hardware platform technologies in general. There's tons of investment in venture capital going into very high impact cream skimming, I guess I'd call, building on the internet and other platforms that have already been built. But what I'm concerned about is what's that model by which we're going to reduce risk, inspire entrepreneurship in these physical hardware areas out of universities and national labs, get the capital that's willing to invest over the long haul, and then get the big companies to come in and actually make sure that this gets scaled in the right way. And so I think we're starting to see some of the puzzle pieces form. When I was a venture capitalist, I remember I was going to hustle. I was going to get out of Boston and the Bay Area, and I was going to go find all those beautiful nuggets in all the other universities. And this was probably a decade ago. I found that the culture wasn't there in many of those universities. That there was kind of, well, if I work with commercialization, I'm impure, and you can't really trust my results, and why would I do that? And they were kind of, I was a PhD MIT person, and they thought I was coming in to do something bad or something untrustworthy. I think that's been changing. So, universities are starting to reorient themselves a little bit. I think there's less long-term research and development happening in big companies for a number of reasons that I'm sure we talked about today. So we do need the universities and national labs to play a little bit more commercially relevant 5+ year out innovation role. And we need to find a new set of investors. And one thing that I'm excited about is we've been working at the Department of Energy to try to find those investors. And so we launched something at the White House called the Clean Energy Investment Initiative, where we got about $4 billion in commitments from new non-traditional investors who want to invest in the long haul in clean energy. They're seeing high net worth individuals is one class that's, they are typically families that have revolutionized industries, and they want to preserve wealth over generations. And so they see the opportunity to revolutionize industries in advanced manufacturing or clean energy, and they want to preserve wealth over generations. And on the other side, we're seeing large pools of capital on the scale-up side, like sovereign wealth funds, endowments, insurance funds, pension funds. They're starting to see that this energy and climate thing is getting more real, and that they are trying to preserve and grow wealth over decades. They probably need some exposure in this area as well. So we're seeing a new set of investors who are trying to figure out how to invest in this area, and we're working with them on that. But what I would say is we're starting to get some of the pieces aligned, but I think groups like the group we're with today, I think we still have some work to do to convene all those players to help invent a new model that's going to allow us to really get these great ideas pointed in the right direction in the national labs and universities, get them on their first few steps, and then get big industries to be able to scale those innovations.
Terrific. Fair warning, we'll open it up to some questions in a couple of minutes, so be thinking. You talked about commercialization, getting the idea out of the lab. Looking at manufacturing specifically, not the app world or the internet-based, how is the collaboration between industry and the lab, industry and academia going? And are there some great best practices everyone should be looking at, or some real challenges that we need to be talking about?
I think it's happening all across the country. I mean, again, to give a local example that I'm familiar with, GE just recently established a pilot manufacturing facility, advanced additive manufacturing facility in Pittsburgh to be close to a university. They looked at 3 different sets of universities, specifically in close proximity to a research university, so that they can have pilot projects. That's one example. And there are many other companies. So this year we signed 4 or 5 new agreements with major corporations from around the world for collaboration. In fact, the largest industrial engagement for Carnegie Mellon happened just a few months ago, and the largest overseas engagement happened a few months ago. So these are examples of collaborations that take place. Another thing that is happening increasingly across the country is that students are getting exposed to manufacturing in many different flavors, not necessarily engineers, but everybody. Here is one example of a pedagogical program that we started last fall. This is the second year. There are 450 freshman students who are engaged in this. So this is called Ideate, to bring design, technology, and fine arts together. Mm-hmm. So libraries where students used to go either to sleep or nobody takes books out anymore have been converted into 3D printing places and dormitory rooms. So students have a purpose now, go to library, not only to find a quiet place, but to make things. And they can do that in their dorms and distribute it across campus. And this is happening all across the country. And this is now creating innovation from art students who do things, not just engineers. We have a faculty member who's using 3D printing to print human tissue. And in fact, he produced artificial hair just a month ago. It was in public media. So there is all kinds of this kind of innovation that's coming through, because now you're opening it up beyond mechanical engineering or a particular department.
So Tom, you might be able to put a 3D printed human into your 3D printed car. What I'm finding in the national labs is where we invest about half of our funds, and so that's a very important relationship for us in this context. And what I've found more and more is once you get, and Tom, I'll call you out again, is we're trying to create the gateway drug of getting folks into our national laboratories. And basically once you get in there and you get a technologist from the company talking to these brilliant folks at the lab, then you see this blossoming occur. But I think, and so there are some companies that get it and are in and have these tremendous sets of partnerships. At our additive manufacturing center and manufacturing demonstration facility at Oak Ridge, the head of materials at Cummins is there 3 out of 4 weeks at the facility, and similar with other companies, other major companies. And we're seeing these blossoming partnerships. And so I think a big focus of ours is how do we get more people in the door? And so doing things like a small business vouchers program where we're investing $20 million into probably 100 to 200 new small business partnerships, by which we'll double the number of partnerships we'll have with small businesses in the labs. Doing technologist in residence programs where we've teamed up 7 pairs of company in the lab to pursue a long-term research agenda together. The PNNL team is working with Tesla Motors, for example, through that program and others. And so I think the more touch points we can get, I think that the thermodynamics are good, but the kinetics are a problem. And so I think the more we can get people over that barrier, the more collaboration we're going to see. So I see a doubling of those kind of collaborations as something that should be very doable.
So I see there are a lot of very good success stories we have throughout the complex where some industries and companies have teamed with laboratories in a variety of areas. You just mentioned a couple, I think. But if you look at the opportunity space, it's very small, and they tend to be ad hoc examples of how did people get connected originally. And so I think where we have a lot of work to do is how can we better do the matchmaking between the capabilities and the interests of the laboratories where people want to make this difference with the needs that are out there in industry. I think things like the programs you just mentioned, so the pilots and the longer-term initiatives are really important. I think also the labs can do a better job of this. One of the things we're looking at and have been doing, in fact, is now a standard part of how we run our internal research investment, our LDRD, which is like R&D for industry, is that in addition to the usual literature search someone has to do before you can propose and fund a research idea, we also require an IP landscape analysis be done. Because we're saying usually a PI will come in with this much proposal, with this much budget, so something's got to give. And we're saying, as you're exploring it, why don't you try to explore those areas that are most likely to result in interesting and valuable intellectual property? And we find in the course of doing that, we then identify potential industrial partners along the way. And we team with them early. And that actually led to some very successful partnerships under the RBE program and now in some of these other areas. I think we can do more of those things like that. These other programs to help the matchmaking, and what we can do to be a little bit more proactive in identifying those partners and doing it. Because when we have the examples, it works very well. I think you can see some real benefits to the economy. We also, I think, have to do things, talk about risk, is encourage our staff to take the risk of going out and becoming entrepreneurs. So we had some staff who were really doing some work in redox flow battery technology, something that's needed for grid storage and other large-scale storage applications. And because of what we've been doing at PNNL and our culture of encouraging this with the support of others, we're able to encourage them to leave the laboratory and go out and start this company, Uni Energy, on the west side in Washington State. In less than 2 years, it's up to over 50 employees selling commercial products based on technology that came out of a national laboratory. There are many examples like this. The question is, what do we do to accelerate the creation and realization of these opportunities?
Subra, did you have a comment?
I just want to add one point. While university, industry, government collaboration is very critical, universities are also in a unique place at this point in time in history, with government funding for basic research stagnant, with industry not pursuing long-term basic research like Bell Labs used to do, or IBM Watson Center used to do, where industry folks publish papers, academic papers, over a long period of time. So if you look at the future of the intellectual horsepower of the country, it's very important that universities don't take a short-term view. So there are very few places, and universities are probably the only place right now where we have to do things just because it pushes the boundaries of human intellect, even if it doesn't have any commercial value tomorrow or the next 5 years. If we don't do it, nobody else will do it. So I want to really emphasize that point, that while I'm a champion of commercialization for Carnegie Mellon, and I try to do that at NSF, I think it's very important that we not lose sight of that important aspect of why the universities exist. Solving Fermat's last theorem is a 100 and 200-year problem. NSF funded it continuously for 20-some years. Princeton University professors solved it. And it's important that universities do it, and we have to do it.
We're going to transition in a couple minutes to a final session on the talent issue. So before I let you gentlemen leave the stage, I just want to raise that with you because it's been a theme throughout our day. Do you get the sense that industry is giving you the right signals as to the talent they need and for the jobs that are going to exist, or is that a feedback loop that still has work to be done?
Well, the Department of Energy doesn't have a huge role in workforce and ed. I mean, the Office of Science funding a lot of basic research, I think, plays a huge role in that capacity. And interestingly, if you look at the national labs versus the universities, in the national labs, a very small fraction of the researchers leave every year, and in the universities, a very large fraction. So I think the universities play a really important role getting that talent out. But I want to talk about one area of talent that I think is underappreciated or under-discussed is this, like the next generation of entrepreneurs coming out of our universities, the technology entrepreneurs, the PhDs and postdocs. And what I found 10 years ago when I was in the MIT ecosystem is dozens of these entrepreneurs were spinning out companies in advanced manufacturing, clean energy manufacturing. And I went back and gave a keynote at MIT recently, and virtually none were spinning out. And I think that has to do with this investment gap in the early stage that we really have to work together to address, and we are working with this Clean Energy Investment Center. But I think that's something that we need to pay attention to on the entrepreneurial side. We could lose a whole generation of these brilliant students who should be spinning out these advanced manufacturing companies if we don't find them a place to go. Very quickly, we're doing a new program at Lawrence Berkeley Lab called Cyclotron Road, where we're spinning in those entrepreneurs into the lab. And we've got 8 entrepreneurs in a pilot program who are spinning in and are going to work on their technology they developed in their PhD or postdoc for 2 years with the lab to incubate it and figure out where it needs to go. We're feeling good about the program, and we're thinking of expanding it to a number more labs.
In the universities, I think we have a building on our campus where 11 different major companies have one room each. And not because they can do anything substantial in that limited space. Companies like Apple, Google, they have much bigger space elsewhere. The reason for that is, innovation is a contact sport. And the more random collisions you have, especially with young minds, the greater the outcome. And so we are actually building more space, and there are requirements for a nonprofit, what kind of space can be used to engage with a for-profit industry. So we're paying a lot of attention to that. And I think that's a very clear indication to your question that industry is paying attention to this. And in fact, this year we had requests from 12 companies for space on campus.
That's tremendous. Steve, final thought?
So I'll take a little bit different perspective on the workforce. And I'll tie it back to the earlier remarks I made about the presentation we saw right after lunch. And if you look at the workforce, whether it's the investment in the new workforce that we need through students and things like that, or I would say, a bit parochially, just in the captive workforce we have called the National Lab Scientists and Engineers, who are there on retainer, if you will, to really work on those long-term problems that also, when there's national emergencies, can be called upon, as they were after 9/11, Fukushima, the Gulf oil spill, et cetera. One of my concerns, and it comes up when I talk to our political leaders who come through and ask what's most on my mind or worries me, and the answer I usually give is the lack of stability in R&D funding in this country, whether it impacts NSF and their ability to maintain appropriate grant pipeline and engagement of students, both undergraduates and graduates, or what it means in terms of my ability to retain and attract a workforce. And when I talk to the laboratory directors who feel the same way, there's a concern. We have very talented people who, when they see the fluctuations like this, especially in the lab part of the ecosystem, they question the country's commitment or value of that workforce, and they ask, should I go somewhere else? And I think we need to have all aspects of the ecosystem be very healthy. We need a robust academic research enterprise. We need a robust industrial research enterprise, and I think we also need the national labs. And we need to be able to keep people in all those. And then again, it comes back to, we need to do that by showing our continued stable investment in R&D. That's what we need to do to have a thriving economy. So
Thank you. Thank you, and thank you to all the panelists, please.
Thank you. Thank you very much.